Hi everyone, in this video we will understand mutual TLS authentication and how it helps services verify each other's identity securely. You might already know about TLS or Transport Layer Security, the same protocol that makes websites use HTTPS instead of HTTP. But TLS normally authenticates only one side, usually the server. In mutual TLS, both sides, the client and the server, verify each other's identity using digital certificates. Let's see how that works. So before we move to mutual TLS, let's quickly recap how regular TLS works. When your browser connects to a website, the server sends its digital certificate issued by a trusted certificate authority. The browser checks the certificate to confirm the server identity. Then both sides set up an encrypted channel using cryptographic keys. This ensures confidentiality and data integrity, but in this setup, only the server is verified, not the client. Let me visualize it. So assume this is a browser and this is a server. So first the browser sends a connection request to the server. The server sends its digital certificate. Finally, they agree on keys to encrypt their communication. This is how regular TLS works. Now imagine two microservices communicating. For example, a payment service or an order service inside a company network. In this case, it's not enough for only one side to be verified. Both services needs to trust each other because they exchange sensitive information. That's where mutual TLS comes in. In mutual TLS, both the client and the server present their certificates to each other, verify those certificates using the same trusted CA, and only then establish a secure two-way authenticated channel. So, in mutual TLS, the difference is that the client sends a connection request to the server responds with its certificate just like before, but this time client also sends its certificate back to the server. Both certificates are verified by the trusted certificate authorities, and once trust is established on both sides, they set up a fully encrypted channel. This ensures that only authenticated, verified services can communicate. Now, the question is, where do these certificates come from? They are issued by a certificate authority, a trusted organization that acts like a digital notary. The process is simple. A service generates a key pair, a private and a public key. It sends a certificate signing request CSR to the CA containing its public key and identity details. The CA verifies the requester's identity and issues a digital certificate signed using the CA's private key. Any system that trusts the CA can now verify that certificate as authentic. This public key infrastructure, also called PKI, is what makes TLS and mutual TLS trustworthy. Mutual TLS is widely used wherever secure service to service communication is critical. It is widely used in microservice architectures where internal APIs talk to each other, Kubernetes clusters to secure communication between pods, financial and healthcare systems where every client must prove its identity, IoT devices ensuring only verified devices connect to the network. It's also a key building block in zero service security where nothing is trusted by default. To summarize, mutual TLS provides mutual authentication, not just one way trust, protects against impersonation and data tampering, builds secure encrypted connections between verified services. It's like a handshake where both parties show valid IDs before talking securely. So, mutual TLS is simply just TLS with double verification. That was all. Thank you for watching.